Welcome to the simulator portion of the Finite State Machine lectures. So this time, and it will work compared to the actual main lecture slides, I will go back to the blank state machine and the example state machine, talk about them again quickly, and then show demoing them running. And then we'll go on to the examples of setting up and working with the actual lock device that we designed before. So again, this first blank state machine example is basically one that you can duplicate and begin with as a starting point if you want to implement a state machine in this course. So if I bring up the code again, you'll see things you need to change of being your states, the output names that you would want for them, and then the individual cases and the code for the transitions and everything that you need. So now again, this one right now basically will be is that it starts in state 1 and then it just outputs a message saying running state 1 and then it automatically transitions to state 2 and then in state 2 outputs a message and automatically transitions between state 1. So it's just toggling back and forth between state 1 and state 2. So this is meant as a blank example for you to copy, and also your very first, very rudimentary Hello World example, where the next one builds upon it more. So to see, you can see there's nothing hooked up here yet. This is just demoing using the internal state code. To see any output, you need to open up the serial monitor. And the idea is we'll start this up, and you can see the output as it continuously runs. So again, these numbers that you're seeing here are those timestamps of being like the clock ticks since the actual Arduino was started up. I just have them here just in case you want to see the sequencing over time of events. This is always the state that the device currently is in, and then you have the output for the messages. And so you can just see it here toggling back and forth. And so I'm going to stop this right here just so we can see one of, you can see, okay, running state 2, okay, here transitioning to state 1, and so forth, and continuing on as it goes back and forth. So not a huge amount to see from this code because not following what's happening here, but it's just showing the idea of going from the start state to the next one and back and forth, and the fact that you could step through this with a debugger, trace it by hand to get comfortable with this, understand what's going on as you step through each state. Now, if we go back, I'll go over to the night-day example now. So this is number 12. Now this is your actual Hello World. So this is with some actual sensors hooked up in analog. You have the LEDs as the actual effectors, and you have it cycling between states. The idea is depending upon the light level, it's going to turn on or off these different lights to actually match. Now again, you could have done this just with an if-else statement in the loop, but this was meant to be as a rudimentary beginning example of working with the state so that it would be easier for you to trace and work with. Whereas the lock example takes that to the next step, and you could, for more complex robots, especially if you're making one that's moving around a room, you could do a lot more with it. So within this code again defining the night and day, and this is just to match up with the original simulator. So let's see, if I open up the actual lecture code, lecture slides, I mean. And we go to the night-day example. You can see with this one we started in the day state. And it keeps running the code here. It's supposed to have in the day state, which is the red light is off and the green light is on. If the photoresistor sends back a reading that is less than or 800 while we're in the day state, we're transitioning to the night state, where then the red light is on and the green light is off. And then in the night state, if we have a reading that goes then greater than or equal to 800, we transition to the actual day state. And so this is like that toggling back and forth one, but now the triggers are actually being controlled. And so translating that again then to code is then first the day and night, just define the states in the enumeration. then the output message just for debugging and making sure that these are in the same order and just having the message that you want displayed when it's the day state versus the night state. You debug, and then because we said the day state is the start state, we set our current starting state to day. We have our pin set up for the LEDs, and then our loop here is now just going to continuously print out the current state. Now you do not need to have this, is just for debugging. You could take it out if you find annoying seeing what state you're always in as it goes through, like keep repeating this. You just have it print it once or change this around as you see fit. But this is the important part here, that it's going to go in and based upon our current state, run a step of that actual code. So within here, I just have the code once again, that is the code to run for it, and then the transition separated. You could have had the transitions also inside of this function, which you'll see in the next example for the larger lock example. So here I have the run day state. So come down here and you'll see I'm making sure I'm setting both lights properly. So the green light on, the red light off. And I'm just delaying now for the simulator so it doesn't go any crazy. You could probably take this out if you're dealing with this your own physical Arduino. Then it's going to come back up and check for that actual transition. So again, that's the transition that we're seeing here. So we're in the day state, we're doing this work of code. That's what's happening here. Then we have to check, okay, is there any of the outgoing transitions, have any of them been triggered? So looking at this, we only have this one here. So that's what you're seeing here, is that I'm getting a reading from the analog sensor, and then if it's less than 800, I'm moving to the next state and setting that. And this is how I set this, and then I'm making sure I'm exiting. Because the idea is in the loop, after this we're going to come down here to the bottom. It's going to come back up here to the loop, finish this function, hit here, loop back up, print out our current state, and go back into the run machine state. And then now when it comes down to here, instead of going into day, this would have been set to our night, so it's going to go down to our night setting. And so that is doing the transition that we wanted to go over to here, which is then going to change the LEDs of red on and green off. And you see the same thing here. And the same work goes for the transition out as you go back. And so it's just going to have toggling back and forth depending upon what we're getting from this light sensor. So let's open up first the serial monitor here. And then I'm not going to show the Arduino, we're just going to zoom in on the photoresistor and lights, since that is where most of the action is actually happening. And I will start up the simulator. So you can see here where it's printing that current state, and it's always doing that continuously. And that could get annoying to see what happened. But I just had it in the beginning so we know what's going on. Now again, as I said, that if you find that too annoying, you can come back up here and then just comment out this line right there and start the simulation again. And we will just start up here. I'm going to stop it again, making sure that everything's clear. And we get that first line, daylight moving to night. Now, the reason for this, what instantly happened, is that we started in the day state. So, like we're right here is the day. We've gone into here, into the run machine. We've gone to the run state machine here, date, gone down here, and would have done the day, so turned on the green. But then it would have done instantly doing the reading that, is this less than 800? And the idea is that in a real light situations that we've seen with the physical work, this photoresistor have been doing different, would have been producing different levels. But by default with the simulator, it always puts it at the lowest value, which would be lower than 800, that we already went through in previous lectures. So the idea is that it starts up, instantly goes into here, okay, we did the day, oh look, it's dark, okay, let's switch to night, and goes back up in the night, and now we're constantly just in the night state. Now if I was to do this forward, is that we're in the day, so it's going day, 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 oh sorry, night, 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 night. Now if I increase this, that this goes above, so even right now we're still in night, and right there we just triggered over that 800. And so you can see the, okay, green light on, red light off, and the idea is that we were in this state continuously until that sensor reading changed. Okay, it changed, so we transition to new state, comes back up and runs this state. And so the idea is that I can go back down, and we're back down to the night, day, night, day, night, day. And that's just based upon that one reading. So again, we have that state transitioning going back and forth. In the beginning, we went here. The photoresistor was less than 0 just because of the simulator, so it automatically then went over to night. Stayed here until night until we changed the actual value, which then it transitioned up and going back and up and back. And that's just the design of this basic night-day kind of device, which in the end, basically, you could turn this into a basic night light, or a device that maybe during the day, when it detects that, it doesn't turn on, but when it's night, it turns on and does some other actual work. Or when it gets dark, it does something else. It's the beginning of this. And so you could take this first basic design and start growing upon this. That maybe you add other states of what's going on, not just this night and day. Maybe once it goes to night, then it transitions based upon other sensors of what goes on, versus if it's the day, maybe it just sits here and does nothing, or vice versa, whatever you're planning to design. So you can keep playing around with this. You can see the changing from night to day, or you can bring it back in and boom, stop simulation. Bring it back in and see every state. So we can constantly see the night, night, night. We can see it here transitioning to the day. Boom, 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 boom. And back down to night. Okay. So I still suggest, even though I'm talking about it here, it's better that you go through and play with this. Like, sit there, trace through each step, get comfortable, maybe try changing up and adding a new state. So redraw the diagram on paper for what you want to have happen in the triggers. Maybe add another state that's midday, so add a third light and have it being midday, and have it transition from like dark to midday kind of light to really bright for really bright day, or whatever you want, and have it transition in different states back and forth and see if you can get that to work properly. What I want to go over now is move on to our bigger example. I worked through that when we designed in the notes earlier on, and we came to here of being the actual lockbox design. So this one being that you had a keypad that would open up a lock and having all of these transitions. So now that we have 3 states and we have more than one basic transition between all of them. Now, before going into that, is that I am just using some LEDs and a servo to mimic being a lock for now. That can be replaced by other devices in the actual future, but we haven't covered the keypad yet. Now, you can look up a lot about keypads, and in the kit and on the simulator, we have a 4x4 keypad, ones that you'll see like here. And so I've created one little simulator and some extra code that shows how to work with a keypad, but also save the keys and realize, well, what's different about this? Because if we go into this, most times you'll jump in, you'll think, oh, it's just like any other keyboard, but we have to really realize this is basically a digital sensor. Is that each one of these little squares here, there is just a little button, a little contact button. You press down, it engages it, and unpress it, it like disengages it. That's not even a proper word, so I'm going to say you press the button versus pressed and unpressed to get the actual like English. So when you have these in here, really this is just kind of a grid connected all together of these individual actual buttons. And in the tutorial book from FreeNova, you will find it if you look up at the matrix or the 4 keypad examples in there where they talk about it a little bit deeper. But the idea is that you have each of these being buttons, they're all connected by grids, and then you have 8 pins here in the end. And the idea is that the first four here, you can see marked slightly different, are considered to be the row pins. So 1, 2, 3, 4. And then you have 4 pins for the columns. 1, 2, 3, 4. And so overall it means that we have the 16 actual buttons, but that doesn't mean that you can see that we only have 8 lines. And so we didn't want 16 lines or extra lines, 1 line for each button. The idea here is that with the device set up in a kind of matrix way, you can detect if this key is pressed based upon the row and column that's given the highest signal. Now, you won't have to do this. There's a library that does it for you, but that's the general idea, is that you have 16 buttons, but only 8 things are taken up. But what you can automatically notice is on the Uno, as I said in the very beginning when it came to controllers, when you're picking your controller, you have to think about, well, what things am I going to have connected? How many pins do I have? And what work do I need to do? And right now, we're just starting with the Uno. And if we just go with using these here, we're like, okay, well, I've got 13 digital pins, but now 8 of them are taken up. And I'm limited than how many PWM pins I have afterwards and what I can do. I'll also mention that these can be on any digital pins except for pin 13. When I was working this, any of the lines that were on pin 13, the keypad would not work properly from there. So just try to keep it between these here. But again, we're limited for the analog and digital we can do. So maybe we could find a separate controller board that would deal with the keyboard for us and sing the signals and maybe take fewer lines. But for right now, with the one we have in the kit, we're limited with this. So we're limited by how many other sensors and what we can do with those sensors afterwards. So first, connecting it up, you can just connect the row buttons to any digital pins. Doesn't really matter the order at all. You just have to remember from your first, second, third, fourth rows, like the order from here that you remember where they are. So which pin each one of these are in that order, and then each of the actual column ones. So that's your first hookup, and that's taking up a lot of the actual pins. So if we go into the code itself, if you look online, you're going to see a lot of these examples. So first, in the simulator, you have to include keypad.h. If you are doing this with the Arduino IDE, be aware that it does not by default generally have this library installed. You can go to the actual library section and search it and install it yourself. There's nothing bad here. You can also go to the link here, and I believe it talks about some of the library. You can find other forums, examples of how to add the library. And when I post the actual physical video, I'll show how you add in this library itself. Other than that, I just have the servo. Now, things that are important for the keys to deal with it, just to set it up, is one, you need to make this character 2D array and initialize it. And what this is just your internal mapping of what character you want to come back when a certain button's pressed. So in this case, when I press 1, it doesn't mean that this thing is sending 1 over the Arduino. It just means there's a little contact switch under here that when pressed down, it'll do the signal. Where it comes from is you can see this 2D array that it's 4x4 matching up to the organization of these buttons. Is that, okay, the top right corner, this one right here, when that's pressed, I want a 1 to actually appear, and so forth. So right now it matches to what you see on here, but you could play with these and have it return back other codes itself. After that are just 2 arrays to indicate what pins you have the rows on. So you can see here this array starting from the beginning, going from the actual left to right, is the row 1, 2, 3, 4, and matching up to what pins those are on in that right order. And then next is in the proper same order following afterwards is each of the column pins. This here will then be the actual object you work with to represent that keypad. So this is built-in functions from the library that will take your 2D array and make it in a way that this class can understand it properly. You have your row and column pins, and then you have the number of rows and the number of columns, which for this keypad, it's a 4x4. After this, what you see down here is a little bit of extra code, is that when you press this, you have to realize it's not the same as a keyboard on your computer. When you press a keyboard on your computer, your operating system is receiving that key and saving it internally into its memory until a program requests to read a key. So if you've been doing any reads or the scanner class, you do this stuff, that's idea is that your process is running in the operating system, and then it's requesting from the operating system, okay, give me back some of what keys have been pressed. So even if your program is doing other things, the operating system is keeping all of the keys that are being pressed by the actual user. The Arduino? No. You have to write that yourself. And so there's different ways that maybe you expect them to enter 4 keys, and you can look up this class through the actual link up here for the library and look at some other methods that are in there and have it block and wait to not go past. But I want to design something so that the Arduino, when it goes to read a key, can save it somewhere, and then another part of the program can request and read out information that it needs. So especially if you need something like, oh, I just don't want them to enter 1 key and then I go do work, but I want them to enter a sequence of keys and I want to save that. So what you'll see a little bit later on is I've implemented what's called a circular queue. So a queue being, you know, first in, first out kind of design as you expect. If I'm typing keys, the first one I press should be the next one that's interpreted by the program and so forth. And the circular one queue just means that it's kind of a circular shape. Now, you guys don't need to know deeper into this. When we get down to the code, I've linked to an example website where I pulled some of the actual code from, and it gives a larger explanation if you're curious. So otherwise, after this, you'll see that, again, it's just the startup. But what I'm doing for right now, at least in this course, not dealing with any interrupts or anything else, other ways you could handle this keys, is just that every single time it goes top of the loop, it checks to see, have there been any keys pressed? If yes, read that key and then save it to the buffer. So my hope is that all of the code's running fast enough that we don't miss it. Because again, if you had a long for loop that's running and it doesn't get back to this save any key press for a while, then the user could have pressed a couple of keys and we've missed it. So for this example, you'll see me hitting the keys slowly to make sure that the program's had time to actually deal with it. After this, all this does is this program waits for a 5-key sequence, and then once it gets it, it prints it out to the actual screen and then just delays for a bit. But otherwise, it just keeps going for this. So these are functions that I have built. So ones that this will save it in here. This one will try to read 5 keys that have been pressed into the buffer. And if it hasn't, it returns back this string that has a length that's 0. Otherwise, it returns one that's to 5. And it'll see where to print out the actual message. And so this is also just showing you that there is a string class in the Arduino language, but it's not exactly the same as in Python or in Java. So you should remember to look up the syntax. So even examples like these things, like the star here, it's called a pointer. If you want to know more about this, I suggest you just look up some of the reasons and how about I just not screw up the code as I'm doing this. Okay. So I've got some built-in functions. So this save one right here key, the idea is that off the keypad, it waits for getting the key. Now, this method called getKey doesn't block, and blocking means it's going to stop and sit at this line. So what happens, this kind of just pulls this keypad here to see have any of the keys been pressed. And so if they are, we're going to come back here and we're going to have a value that's positive. So if this is a negative, it's going to be considered false, or like 0, it's going to be considered false. And so it won't go into this if. So if there has been no key pressed, it's going to skip over this, go past. If a key has been pressed, I just have a debug message to print out saying what key's been adding. And then we're enqueuing, so we're adding it into our queue and saving it. And then for right now, I just have this method here for printing out the queue for debugging senses, is that I've added in an extra debug method. So this is just for any debug messages. And then there is also a debug boolean for if you want to print out the key buffer or not. Okay. Now the enqueuing and dequeuing thing, I'm not going to go into that more. There's the code right here. It's using just a singular array to implement a circular queue. So you have your abstract data type for everyone who's been in the data structures course or not. If you want to know more about this, you can go to this website right here. This is where I pulled this code from, and they have a nice example breaking down how circular queues work and showing code examples from different languages. So this part's not important for you to understand. It's just the fact that if you want to read in a sequence of keys and do other work at the same time, you need to make some memory storage of where to store those actual keys. Now, the get sequence right here basically is just checking, okay, as long as you have given a number of keys, okay, see how many keys have been in the queue. So this is a global variable that's updated by the enqueue and dequeue. Then otherwise, it just takes out that many keys in the right sequence and returns it back. Otherwise, you get back a blank string. So really, in the end, this just allows, as long as you have this function first here and it's not delayed a lot, you'll keep getting keys, they'll be stored. And then once we hit 5, this will eat up and take 5 keys out of the actual queue and start doing work with them. And so this is much more helpful if you want like a sequence of values, which when it comes to the full example for the lock where we had sequences like the 1, 2, 3, 4, well, I need to see that they've pressed 4 individual characters in that specific sequence. And this helps me using a queue and this to actually solve that problem. So if we open up the actual serial monitor here, again, this is where you'll see most of the output. Oh, come on. And then we'll just make the keypad a little bit bigger, and we'll start the simulation. So you can see machine is starting up, nothing else has happened. So nothing will happen until I press a key. So right now, just sitting in that loop, no key is pressed, so it's just going through loop, loop, loop. So if I press 1, see it's adding key 1, and this is the key buffer starting in the very beginning to the end, so the order of the keys. So you can see where I'm going, like 2, 3, 6, 4, 5, 7, 9, A. And so you can see each time of there's the key press and there's being added the queue. So again, where it's always added to the last, and we can see from the first to the end the sequence of what's currently being saved into that queue, and nothing has been read out yet. And you can see we've got 1, 2, 3, 4. So one more key press and that code for the sequence of 5 should read it and remove those from the actual queue. So I'm just going to press a C. So you can see you're pressing C, here's the queue. You can see, oh, this is the actual sequence message right here. So it was actually able to read 5 finally. So returned a string that was greater than 0. And then that would remove all of those 5 keys from the actual buffer. And then, boom, input it right here. Now, be aware for this program doing at 5 is that there is a limitation to the fact that the buffer size I've set is to 20. So you'll see it up right here. This means that at any time, this thing can store up to 20 keys. At that point, when you hit 20, it'll just stop accepting keys. So like this, you expect, like if you're expecting to read frequently out of this, you're okay. It'll put 5 in, take 5 out, and there'll always be extra space. But if you hit that size, it'll be larger. If you think it should be larger, you can increase this number, but be aware, the larger you increase that number, the less actual memory that you have for the rest of your program that's running on the actual Arduino, since you have a limited size. So I've just set it to 20 because I don't see like you're going to have longer than 20 keys that are pressed before you're actually reacting. And that could be shortened depending upon your actual program. So you can see I've got 1, 2, 3, C that's red. I'm just going to press the 2 again. And you can see again that our buffer is now empty from here. And if I keep going up and hit that 5, you can see there's another 5 keys, so it's taking them out. And we have them in that right sequence that we actually expect. So my hopes in this is just to kind of build upon some of the examples that you'll see online, because I built from those as well. But I find they don't add a whole lot more into what you can do. It's like usually a cut and carbon copy paste of this without really explaining and changing stuff of what's going on. Whereas I was adding in also this stuff for doing the debugging and also showing you the actual queue itself, like having a circular queue so that if you want to save sequences of keys over time while you're doing other work. So you could be flashing a light and waiting for them to enter keys and doing other work, or checking if you should be making transitions while waiting for the actual keys, and not having something where the entire program's locking up until one state happens. And you'll definitely see that when we get to the lock machine, when you have the hypnotic lights that are supposed to be moving and waiting for it to. Like, you don't want to block for the key to come in and not change the lights as you expect. Okay, so I will now go back up and go to our locking example. So this is now a much a bigger example and showing everything coming together and actually it's like functional design to ours. We don't have the physical structure where we'd place this, which my hopes in the physical video is to actually show that, but having this overall here, using a state machine, going through and taking that original design that we implemented here and putting it fully within the code and actualizing everything that's going on. So within here we have the keypad again, and then now to work out everything as well, to have a servo, I need to have 1 PWM pin free, so that's okay. I have then 3 LEDs, which on each one. I wanted to have some fading, but then we were limited again because no matter which way I was trying to shift these around, it doesn't leave really like many other PWM pins, so I just left it as being a red, green, and actual white LED. So at this time, we've designed like this is fine enough for the product I'm designing here, but if you decided that we went to the implementation phase, maybe a different controller board would be better. Maybe the Arduino Mega that has like quadruple the number of actual ports you can connect stuff to. Maybe looking up if there's other controller boards or chips that would handle some of this other work and take up less pins here and let us connect things together, like controlling multiple LEDs with a shift register or things like that. but we're limited in this case, and that's what you need to take into account when you're designing projects. You can't just, I'm going to have all these sensors and do everything else. You're like, hey, what's physical reality? What controllers do you have access to? What can you do with them? And how can you connect it up? And is this even feasible in the first place? So this is everything else here. A locking mechanism, you have the LEDs, and you have the keypad. And the idea is that for this locking mechanism right now, I'm just having it simulate it, that when it's at 90 degrees like this, it means the lock is engaged. And when it's at 0 degrees like this, it means the lock is actually open. And you can see the rest of the lights doing their fun job. Now, coming in here, again, I've got everything else set up. I've got my keypad, the same you saw before in the previous example. I've got my actual buffer and everything else that I actually need for code with it. I then have my merging in that blank static example. So I have my locked, unlocked, and hypnotic. So again, matching up to what we have here, locked, unlocked, hypnotic. The output messages, the debugging, I have one for true, and the printing out the buffer for right now I have true. So here's your two debug methods where you can turn off the printing of the keyboard buffer. And you can turn on or off the output of any of the actual messages as they're going out. I have everything on just so you can see as you're hitting the keys where it's saving it. You can see when it gets triggered to go to the actual next state and step through it. So we got our servo, we have our light constants, you have your setup of everything else beginning. And then you can see here where I've got the save any key, the run state, and the delay. And what I've tried to constantly do is that in my run state, I am making sure I don't have code that's running for too long so that it only runs for a little bit, comes back here, and we'll save another key so we don't miss any keys. Now, while working with the simulator, I found things work weird, so I just made sure that I press the key slowly, like going 1, then 2, then 3, and not trying to press them too fast, just because it depends how your own machine, a simulator running on it, and how things are going. So within the actual run states, this time to keep the run state method a little bit shorter, I haven't included any transition. I just have the case for each state, so the locked, unlocked, and hypnotic. And then I've made a function to contain all the code that would be run in that state and the checking for transitions, just to make sure that this looks cleaner and easier to add to. And then down here, I've just included any global variables for the run unlock state, so it's easy to find with this code because this variable is only used here. And then I have all of the code for this method. Now, when this comes in here, this is just going to, again, lock the device, is what it said. That was one of the first things it was supposed to do, is that we had the describing of the actual states. And then it sets the red LED to high, and then make sure that the rest of them are set to low. And then this if statement you're seeing here with this boolean is that I don't need to, even though we're in this state and it's going to keep coming back here to run it, I don't need to call these functions anymore. So you could have ignored this. I just wanted to see what it would do to remove this so it's not wasting cycles or extra work or anything else, or making like the lock device act weird. And so here is just the first time it comes in here, it's going to run it, and until I leave from here, this won't be changed. I just have to make sure before I leave this state, I set this back to false. After this, I am waiting and doing, so this is the code here for actually running. So this is the actual code for running what happens in the state. This is the code for checking for the transition changes. And so when you're in the lock state, you have a wrong code, so we stay here. We either have a code of 1324 to go to the unlock, or 1234 to go to the hypnotic. And so you can see they're both sequences of 4, so I'm just wait, and I designed that specifically so they're not differently. So it's easier to deal with for the code, is that same keyboard code that I just showed before. You have it here where we're waiting to wait for 4 keys. When 4 keys are actually entered, we just check and see which one was done. So if it's the 1, 2, 3, 4, we're supposed to be transitioning to the hypnotic state. So make a message saying we're doing that just for debugging. Change your current state variable to say that's the next state we're going to run. And then do any cleanup that you need to do before you come back to this state. So the idea is that when it comes back, you should be back to the initial settings and everything expected before. And you need to update your variables for all of that. So in this case, that's why I've got this lock state. So if you've got other global variables that you're keeping track of information that should be reset to initial conditions, you would do it here, or you can leave them to whatever value it was, depends upon your actual design. Other than that, you can see the next for me checking the 1324 for the unlock state, and same thing. And then else here is just outputting a message of unknown code, but the idea is to do that little loop that we'd see right here and not change states. Just don't change the current state value. We could just do whatever we want to indicate unknown code. So I'm just having it print out a message for now. Maybe you could have it flash the light in a different way to indicate to the user that that was wrong. And then it's going to come back and stay within these states. So you can see similar things then for the unlock state. I just unlock the device, change the LEDs, and mark that this code's been run so it doesn't continuously keep running this while we're in the state. And then next, check for the transitions out. So same as before. And then here we have something different is in the hypnotic state. I'm just having it cycle through that it goes red, green, yeah, white, and kind of like red on, off, green on, off, then white on, off, then back to red on, off. So it kind of looks like the lights are chasing each other hypnotically from right here. But the idea is I don't want to have a loop that's doing that, because at the same time I'm changing between light 1, 2, and 3, I also want to be able to go back and read keys and check for that. So I have to do two kind of tasks simultaneously. So it's not exactly asynchronously, but we're doing a little bit of one task and then the next. So instead of having the loop, I have a global variable to keep track of what's the current LED that I'm on. So it goes into here and then changes all of them and make sure that I turn on and off the ones I expect, not just the one I want. And so taking it on and off, which one's next, which one's next from right here. And then I have this one line here that'll increment 1. So go to the next LED, and then I have mod 3. And the idea is that if I've reached the end, so I'm at light 2, which should be like the white LED. I go to 3, I want it to wrap back around. So it goes back around to 0. So this will continuously keep going forwards. Then otherwise it waits and sees if there's one key press. If there's not, goes to the next light, and then goes to the next light, and it gives a chance that you're doing one light, check for key, one light, check for key, one light, check for key. And at the point in time, we're waiting till we get that one sequence we want from there, and then transitioning back, and then always doing our cleanup. So you can see if it's 2, we're going back to lock state. And this is all just following the same diagram that we're here, going back to 2. And the idea, this made it easier when to implement everything, because I just went, what are the transitions out? What's the code that has to happen here? And test to make sure it works. What's the transitions that go out? Okay, add the code to check for that. And then change the states properly following my actual diagram. And so you can see what's going through here as these steps. And you can see here, here's my cleanup for the hypnotic states. Once I leave here, is the next time I come back, I want it to be at the right starting actual state. So let's say it's 1. I want this to come back and it's starting at that proper state and that we're okay. After this, so again, I'm talking a little bit fast with these things, but I think it's better that you sit down and play with these and say, try to modify, maybe change the codes you'd expect, change the sequences. Add in another state and get it to do something different. So take the original diagram, draw it out, add a new transition state, and then go through updating all of this code to get it to work with that new state. From there. Now my lock device and unlock, again, it's just the servo 90 and 0, and I just made these functions so it's easier to read and change in the future, and having the slight delay to allow the servo to reach the point that you mark it at. After that, the rest of the code you're seeing in here is just all the code for the circular queue, same as that key before, and then our new method here for printing out the actual case. So let's start this whole thing up. This whole thing that I like, but I don't know if you show it to a lot of other people, they're probably not going to be that impressed. But this still shows our first level of getting to, from the beginning of the course, of having things that are devices that don't do much to stuff that actually does something for us in this plan. And then the next step is to put this into a physical device. So when I start this up, remember that it's beginning in the lock state. So you will see it go in, the lock close, and the red light go on. To monitor everything else, we can want to open up the serial monitor here and watch it. So you can see here, lock state, machine starting up. So it's the automatic start state. And so the idea is that when the code came down to our lock state, so here, lock state, the run lock state, which locked it, changed the actual lights, marked this here, and then kept checking for transitions. And now it's coming back, skipping over this code for now, and just continuously checking for new transitions. So one is I can have a wrong code. So if I go like 2, you can see that this is debugging that 2's been pressed. There's a 2 in the key buffer. And so nothing will happen until we get 4 codes. So this thing right here is 3, 4, 8. Now we finally have the rest of these codes. So you 2, 3, 4, you have 8 going in. You can see it's unknown code. 2, 3, 4 is what it actually read out. And you see nothing has changed here because we've stayed in the locked state. Versus if I put in that 1, 3, 2, 4, and this is where you can see these cases where I pressed the keys too quickly and I didn't have time to read. And this is issues with the simulator. I put another key, it's going to say unknown code, but I'll go 1, 3, 2, 4, giving a slight delay. Boom. You can see they changed to unlocked state. You can see this opening up and you can see the green light on. And so that was the transition going back from here that we were in the lock state. So the first one is we had the wrong code. We went here the second time for the actual wrong code. Then we put 1, 2, 3, 4. So it transitioned over to here, is now running the lock code and waiting for the next thing that we actually have to enter. So if I wanted to go from here back to the actual lock state, I could put in a wrong code. So 2, 3, 5, 6 is a wrong code. So we've stayed in the wrong state. This is locked. This is correct. If I want to go back to the lock state, it's 4, 2, 3, 1. It's part of design. You can see green light off, red light on. This is then in the actual back to the lock state. You can see it all through here being key press being added to the buffer. Once there was 4, it was red, and we're in the unlocked state. We're changing this to locked. And one thing to notice when you're doing the print messages, just the way I've set this up, always do your prints first and then change this variable. When this prints out, it just reads whatever this is and outputs that message. So if I had this line above here, it'll then output saying the wrong state right here. It's just part of my design that I dealt with. Can be fixed by other people in the future, but it's good enough for right now as long as you do this printing and then do this outwards, just for our debugging sense. Now, if we want to check the transition, so what we've done here, going back to our state, is wrong code, wrong code. Okay, right code, we've gone here, we've gone to wrong code, then we've gone to right code, and we've gone back to here for this locking. What I'm going to show next is, okay, we're going from here down to the hypnotic state. So here, at any time, it's just 1, 2, 3, 4. And there we go. We've gone down to the hypnotic state. So it stays in the lock because when you're hypnotic state, it's supposed to stay in whatever previous state you were. So we're in locked. And then now you can see this thing where it's cycling through each of the lights, so a little bit. So it looks like it's a rolling kind of lights as you see going. And the idea is that it's still waiting for the actual key. So I can press any key. Like I could press 6. And you can see that even though the lights are going here, we still get here and saying unknown code in the key buffer because it's only waiting for 1. And the idea is here, wrong code, so not a 2 or 3, it just keeps staying in here. So as long as I keep pressing like wrong codes right here, this will still be able to read it. And I'm kind of mimicking doing 2 things at once and have the lights still go and I can still wait for any code that I expect. So now if I go back and say I press 2, which is supposed to take us back from right here to the lock state. So the lock should still be closed and everything's set up properly. So I hit 2. 2. We're in lock state. This is red. This is locked here. I can then go 1, 2, 3, 4 back to, oh, you can see here and why I had the buffers is I pressed the keys too fast again. 1, 2, 3, 4. I think there's a lot of part of that issues here is with the simulator. Once we get to the physical work, I'll test this again as well. So we're in this state now. If I press 3, and we're down here. So we've gone up, we've gone down, then back up, and we're going back down. Now if I press 3, we should go to unlock. And so from here, it should, boom, go. You can see open the lock, do that transition. I can then go 1, 2, 3, 4 to go back to the hypnotic, and we still see we have it right that we went from the unlocked back down to the actual hypnotic. And so this is open, we're still okay. I can press codes here, we're fine. And then I could press 2 now and go up to the locked, and we're fine. We've done that transition. So this was an example of we're going locked, down to hypnotic, up to unlocked. which then went back down to hypnotic, which then went back up to locked. And so that was just me kind of systematically trying to test that every transition is working properly, that I should be able to go through the sequences of going here and checking. So I could even do more ones that were in locked. I could go to hypnotic, 1, 2, 3, 4. We're in hypnotic state. I can go 3, and go to the unlocked state. I then should be able to go 4, 3, 2, 1. Oh, I forgot my own code now already. 4, 2, 3, 1, which then should transition us over to the actual locked. So I've gone hypnotic, so lock, hypnotic, unlocked, and back. So I've done a whole cycle that way. And now I could check this way, and back up this way, and basically keep trying to systematically test each level to know that I have it right. But I have a working device that does what I want. It's a locking thing. The servo won't lock anyone else, they could break it, but you could change this with the solenoid or other things, or if we're just doing this little test thing that I'm going to try showing with cardboard in the physical video, is showing, well, now where we place these things and actually have the servo actually open up an actual door or remove itself from being an actual barrier from actually doing that. So this is where I have the physical, the electronic stuff hooked up. I have now a little bit more intelligent code in my actual controller to react and change with states for a little bit larger of a project. And next I need to worry about the actual physical body. How do I place these things and other physical things so it completes the overall task that I want to do? So we're hitting now 46 minutes. So I'm going to stop and say once again, you should be playing with this code. Make a copy of it, which I see when you guys make copies. Make a copy of it. Go in and just design and add another state into this and get it to react a different way. Maybe a different sequence that goes into hyper-hypnotic or partial lock or something like that. And so just add in your new transitions and designs and see if you can get everything to start working properly with it so that you get comfortable with this, because you're going to have to start designing and building upon things in the actual future. Okay, and as I've said always, please take care of yourself. Please check in with yourself and with other people and make sure they're okay. If you're watching this video now, maybe send an email or a message or give someone a phone call that you care about and just talk to them and make sure they're okay. Maybe take a step to talk to yourself and realize, are you actually doing okay? Is there anything else you can do to help yourself relax and make a better strategy for how you want to step forwards with everything in the future? And continue being the great people that I know you are. And if you think you're not great, you're wrong. I'm right. You are great. And toodaloo for now.